Good morning. This is the next video for AP Stats Section 8.2, and we're going to do two things. We are going to learn how to use the calculators to save a little bit of the arithmetic for calculating the interval, and then we're going to determine a sample size, because there's often in the real world, the question would be, how many people should I talk to if I want to be so confident and I know what the interval, what my margin of error is going to be. So we'll get to that next. So first thing I want to do is I want to look at one of your homework problems that you maybe did already. It's number 40. And I want to kind of go over it and then also show you how you could find the actual interval, which, remember, in this panic process is only the I part of that, using the calculator. So let's say 2010 Gallup poll asked a random sample of adults. I already like the fact that it says that just as I'm reading this. In general, are you satisfied or dissatisfied? In all, 256 said they were. The remaining 769 said they were not. Notice that kind of just the way this is presented, it doesn't even give us the sample size. Like, we'd have to add those two numbers together, 76, 86, 96, 1011, which I think is 1025. So it could have said 256 of the 1025 people said they were satisfied. Remember, it also could have said there were 1025 people, and it could have given you what percent. That would be actual p-hat were satisfied. So again, it could present the information to you a few different ways. This is the way it happened to present to us. Construct and interpret a 90% confidence interval for the proportion of adults who are satisfied with how things are going. Now, you could argue, what in the world does that mean, satisfied with how things are going? But for the moment, let's ignore the vagueness of that particular context. So whenever you see construct and interpret an interval, you've got to think panic. You have to think that. So here we go. I've already done some of this. P is the parameter. So the parameter is P, the proportion of adults who are satisfied with the way things are going. Remember, the parameter we're trying to find the interval for is not p-hat. P-hat is my one sample proportion, which I will use to do the math. But the parameter is always just either P or mu. We haven't gotten to that. Section 8.3 is the mean. So that is the parameter. Now let's talk about the assumption. Remember, there are three of them. It's got to be random, independent, normal. And you have to list them all out and kind of do enough math to justify that they have been met. So random, it's given, right? So the poll asked a random sample. So this one I can just say given. Check. For it to be independent, that was our, is the population big enough? Independent is capital N greater or equal to 10 little n, question mark. You have to know, is the population at least 10 times as big as the sample size? Well, we figured out up here, the sample size was 1025. Yeah, sample size is 1025. So that means capital N is 10 times 1025, which is what, 10250. Is the population at least that big? Notice this problem doesn't give us the population, but we're talking about proportion of adults. So you absolutely could say, I don't think I typed it in here, that would have made too much sense. I think you could absolutely, you have to do that math, calculate big N, the needed sample size, or I'm sorry, calculate 10 times little n. And I would just say, clearly or surely there are at least 10250 adults. Like, the population, certainly there's more than that many adults out there. So I've said that condition has been met. Check, it's independent. The next condition we have to check is it normal? And I should have, let me hide this and let me extend this. And remember, that is the conditions you have to know to check. You have to know, is NP hat at least 10? And is NQ hat at least 10? You have to know those are the conditions that need to be met in order for this sampling distribution to be approximately normal, which will allow us to do the calculations that we want to do. Now, let me remind you the more you know about this, the easier this is. NP hat. Officially, and there's absolutely a shortcut here. NP hat would be the sample size, which is 1025, that's N, times the proportion of them that are satisfied. Wasn't that, what was it, 256? I forget what the number was. 256. Isn't that just times 256 over 1025? Well, guess what that simplifies to? That's just 256. Remember, if the problem is nice enough to give you the number of people who either said yes or said no, those numbers, the yeses and the nos, are NP hat and NQ hat. So that's NP hat, which makes NQ hat, oh, I went too far, which makes NQ hat the other 700, was it 69? Or I forgot the number, 769. The problem could have just said this. Again, this confuses people every time I do this. The problem could have said this: n equals, it could have given you the total sample size, and it could have said the sample proportion is 0.37. Like it, and that's not the right number, but it could have just given you that. Then you would have had to have calculated n times p hat and n times q hat to see if they're both 10. But this problem, since it gave you that 256 and that 769, you've got to know, wow, that's awfully friendly. That is NP hat is 256 and Q hat is 769, and they are in fact, and you have to write this on your answer. Those are both at least 10. So all my conditions have been met. It's random because it told us. It's independent because the population is at least 10 times bigger than the sample size, and it's approximately normal because NP hat and NQ hat are both at least 10. So we're done with the assumptions. Next is just the name of this test. And that's the only name we know. It's a 1 proportion Z interval. Again, we'll learn more in 8.3 and other names of intervals. Now, as far as calculating the interval, I'm going to do this the long way, which is how you would have done it for this homework assignment. But then I will show you when we're done how to use the calculator. So you have to know that formula. The confidence interval for a proportion is p hat plus or minus z star times the square root of p hat times 1 minus p hat all over n. Now let's start plugging in numbers. What is p hat? P hat is my sample proportion. Well, that's just 256 out of 1025. And notice that, actually, I plugged everything in here. There's 256 divided by 1025. There's no reason to make that a decimal right there, because all you would do would be round it, and you're losing accuracy. So don't round anything till the very end. But that's p hat. Now let's do this. Let's do some color coding here. My p hat is this. Now let's talk about z star. That's this number. Remember in the video yesterday, Wednesday, or the lesson Wednesday, we came up with Z star numbers for lots of different confidence levels. You need to have access to those somewhere. For 90%, the Z star is 1.645. Let me remind you, you would not have to do this if you had this list. But if I went like this and I put 90% in the middle, which of course would leave 5% there, and we'll leave 5% over there. If I wanted to know that Z-score, since there is to the left of that 95%, if I inverse normaled 0.95, I would get 1.645. That's where that comes from. I'm telling you, just know those numbers. And then square root of p hat times q hat over n. Notice I will continually interchange q hat with 1 minus p hat. They're the same. So my p hat here, let's keep going color coding. My p hat, that's still just 256 out of 1025. My 1 minus p hat, well, that's just the rest of it. That's the other 769 out of 1025. And the n is my sample size, 1025. And what I would do, what I did the first time on my calculator, is I just typed that in, that whole equation, carefully with parentheses and square root. I did it first with the minus sign, and I went back and did it again with the plus sign, and I got the following interval. I got the interval from 0.2275 to 0.2720, which does turn out to be the right answer. Let me remind you, if you just would have calculated p hat, like if you just would have done 256 divided by 1025, you should get the middle of that interval, but you do. So there's the interval, and let's finish panicking before I go back and cheat with the calculator. So then my conclusion in context says this: we are 90% confident that the interval from 0.2275 to 0.2720 captures P, the proportion of adults who are satisfied with the way things are going. So I just did question number 40 for you, which is one of your homework assignment, one of your problems from the other night. So there's a good review of panic. Now let's use the calculator to do that I part. So all of this math in here, you don't need to show all that. And even on the AP test, you may use a calculator to do that part. Nothing wrong with that at all. You still write in what you're doing with the calculator, and I'll show you that. So here's how we use the calculator. It says using the TI83 to calculate the interval. You go to stat, and I'll My format has always been, you go to hit the stat button, then you go over to the right to where it says tests, and you've got a lot of choices in that menu. You want to pick one proportion Z interval. There's also one that says a one proportion Z test. Not text, test. You don't want that one. We'll need that one next chapter. So be careful. One proportion Z interval. And then, actually, I need you to want to look. I think most of you have the same operating system on the calculator as I do. It'll ask for X and N and the confidence level. If your format looks different, let me know. I can help you figure it out. But I think you can. X is how many successfully were satisfied. So in this case, that was 256. The N is a sample size. That was 1025. And then the confidence level was 0.9, was 90%, right? So you'd have to enter those three. And so sure enough, I can do this real quick. Not there. Stat tests. Let's see, one proportion Z interval. My X is 256. My N is 1025, and my confidence level is 0.9. Let me just show you this real quick. I think you can see that. Like there I am typing in the X and the N and the confidence level. I just hit calculate. Sure enough. And there, like there's, I don't know if you can see it or not. There is the interval that we calculate, 0.22752 to 0.272. Notice it gives us p hat, not that we need it. So you absolutely may use that. Now, as far as what you would write down, you would write down that's a dash, one proportion Z interval, and you'd write X equals 256. N equals 1025, the confidence level equals 0.9. You would write down this, and then you would just write down your final answer of the interval. So whenever you're finding a confidence interval from now on, you can just go right to there. Now, of course, remember, if the question just wants the margin of error, you may have to do some calculating. If it just wants the critical value, that's that 1.1645, or yeah. If it just wants the standard error, that's just that square root, p hat q hat over n. So you might, depending on what the question asks, have to do one piece of the calculating. But if it wants the whole interval, I'm telling you, use that command. All right, so that's it for how to use confidence intervals. And now let's talk about sample size. So it says this. It says how big a sample? It says if you have a desired margin of error and a known confidence level, how big should the sample size be? And in the real world, this is very common because, as you know, sampling people is not free. And while it would be better to sample more people, there's cost involved. So if, let's say, I know I want a margin of error within 3%, like in all these political polls, that's a fairly common margin of error within 3%. And if I know how confident I want to be, let's say I know I want to be 95% confident within 3%, or I want to be, I don't care quite as much, maybe 80% confident within 2%, whatever the numbers are. If I know those two numbers, the question that you'll be asked is, how big a sample size should I use? How many people should I talk to so that my result will be 95% confident within 3%? So here's this formula again for confidence interval. And for this particular problem, all I care about is the margin of error, which is that thing in the red rectangle. That's the margin of error, Z star times the square root of P hat Q hat over N. And I want to somehow solve that for N. Like that's what I'm hoping, that's why I want this says solve for N. So let's look at an example, and then we got to figure out what numbers to plug in where, and we have to do a little bit of algebra to actually solve it for N. So let me go over here, and okay. So there's this formula for just the margin of error, the Z star times P hat. Now, let's, as far as what numbers we know, first this line right here says if we know the confidence level, we know Z star. So if it wants us to be 95% confident, I know that's 1.96. If it's 90% confident, that's 1.645. And then again, you need to know those numbers. But the problem will tell us that. So we'll have a number for Z star. So we'll have a number for that, which is good. Obviously, we're trying to solve for N, so we will not have a number there. But now the reasonable question is, what about P hat and 1 minus P hat? Like I don't have numbers for that. I haven't even chosen my sample size yet, so I haven't taken the sample. So I haven't calculated P hat or Q hat. So we need to use numbers there. So we've got two ways we can get around that or deal with that. They say this. So it says, but what should we use for P hat and Q hat? We don't know these yet. So one of two things. Sometimes a problem will give you prior information. Like last year, 72% of people liked pizza. If it gives you that, use that for P hat. If it gives you no prior information, just default to 0.5. That will be as conservative an estimate as possible. So that'll actually make the sample size bigger than if you know a prior information. But either one of those is fine, depends on the problem. So then you're going to plug in a number for P hat and then a number for Q hat, and then you're going to do the algebra to solve for N. Remember, the ultimate question is how big a sample should we use? So let's look at an example. It says this. This is right from the textbook. Refer to the previous example, which we don't even need to worry about now. Okay, in that blue highlight, in the company's prior year survey, 80% customers said they were somewhat satisfied. So that particular line right there tells me that I'm going to use for P hat, I'm going to use 0.8. If it would not have told me that, I would have had to use 0.5. But then in yellow here, it says, find the sample size needed for a margin of error of 3% at a 95% confidence level. So 95% confidence level, I know that means Z star, I happen to remember that for 95% is 1.96. That's the Z star for 95%. And it wants a margin of error of 3%. So go up here. Here is that says margin of error less than or equal to 0.03. That's 3%. So here's my formula for margin of error, Z star times the square root of P hat Q hat over N, less than or equal to 0.3. Now you'll notice I plugged in numbers here. I replaced Z star with 1.96 because that's the critical value Z star for 95%. And then notice for P hat, I used 0.8 because this problem told me a prior year's number. For Q hat, I used 1 minus P hat, which is 1 minus 0.8, which is 0.2. And there's that N I'm trying to solve for. Now, you then have to be able to do the algebra. And we don't do a lot of algebra here. You need to be able to do this and solve for N. And I am telling you, don't decimalize or round anything until the very end. So let's solve this for N. So first thing I'm going to do is I'm going to divide both sides by 1.96. And I am not going to write what it equals. I'm literally just going to write, this leaves me with the square root of table. Then we'll also just do 0.8 times 0.2. 0.8 times 0.2 is 0.16 over N is less than or equal to 0.03 over 1.96. Do not simplify that yet. You will round and you will lose accuracy and you will get the wrong answer. So let's keep going. Now I want to solve, the goal is still to solve this for N. Next algebra, I need to get rid of that square root sign. I'm going to square both sides. On the left side, that just gets rid of the square root. So I now have 0.16 over N is less than or equal to 0.03 over 1.96 squared. Still not making that a number. Now what? Since that N is in the bottom, I want to multiply that to the other side. So I'm going to multiply both sides by N. All right, so now I have 0.16 is less than or equal to 0.03 over 1.96 squared times N. And now lastly, to solve for N, I'm going to divide both sides by that whole thing in parentheses squared. So I'm dividing both sides by this whole thing. We don't feel like writing underneath both sides. But that turns out to be, N is over here. There's the symbol. This is 0.16 divided by 0.03 divided by 1.96 squared. Now and only now will I get out a calculator and do that math. Very carefully in parentheses. 0.16 divided by parentheses. 0.03 divided by 1.96, the quantity squared. Turns out to be greater than or equal to, where am I, 682.95. And it's great, and we always want to go up to the next integer. I can't sample 682.95 people. But it's not a rounding thing. Like if it said 680, if it said 6 682.04, I would still go up to 683. So the answer is I would need to talk to at least 683 people. That's an example of finding the sample size. I'm not going to do the last part, but number 2 says, how would it change if the only difference was 99%? Well, 99% is, that has a different critical value, which is, I think it's 2.526. Hold on, 2.576. So other than that, the process would be exactly the same. So there you have it for calculating how big a sample size needs. So again, we accomplished 2 things today. We went over number 40, and I taught you how to use the 1 proportion z interval function in the calculator to find the interval. And then we saw a couple of examples we had to calculate how big a sample do we need. And your assignment is that 506, 43, 46. And from now on, you can always use that shortcut to find the actual interval. All right, that's all I've got. I'm going to find this thing again. Enjoy the rest of your Friday and have a great weekend.